In this problem, we're going to find solutions in the complex number system. In other words, we're going to include answers that have the imaginary number I. We won't just say they're not real. We'll actually write them in terms of the imaginary number. Okay, so the problem that we're going to solve here is an equation that's second degree in one variable. That's called a quadratic equation. And it is x squared plus 6x plus 17 equals 0. Well, the good thing is it's already set up in ax squared plus bx plus c equals 0 form. So the first thing we do, recall how we discussed in a previous note how to use the quadratic formula for solving a second degree equation like this. The first thing we need to do is identify the a, b, and c value in the question. So we have to model the question, x squared plus 6x plus 17 equals 0, with the standard form ax squared plus bx plus c equals 0. Comparing these two directly, we see the a value is a number that's multiplying x squared. The number in front of x squared, in other words, it is 1. And then the b number is the number multiplying the x term, and that is positive 6, and the c number is a number added at the end before the equal sign. That's positive 17 in this case. The next step, since we now know what a, b, and c is to write the quadratic formula. It helps to write it out each time you use it. It helps you memorize it. X equals a big, tall, long fraction. The top is negative b plus or minus the square root of b squared over 4ac, and the denominator is 2 times a. Now we're going to rewrite that formula, but in place of a, b, and c, we're going to leave parentheses. This is very important. It equals negative parenthesis plus or minus the square root of parentheses squared minus 4 times parenthesis over 2 times parenthesis. Now, after the parentheses are written, you can go back and fill in the numbers that I put here. In the b parentheses, put the number positive c. In the a parentheses, put the number positive 1, and in the c parentheses, put the number positive 17. If the numbers a, b, and c happen to be negative values, you would put the negative value in the parentheses instead of the positive value. Okay, now the reason we use the parentheses is to keep ourselves honest. We don't want to screw up with the sign being wrong. Okay, now let's drop the parentheses and start simplifying. We get x equals, in the numerator, we have negative 6 plus or minus the square root of 36 minus 68 over 2. That can be broken apart as negative 6 over 2 plus or minus the square root of negative 32 over 2. And then we simplify further by factoring the square root of negative 32. And we get negative square root of 16 times the square root of 2 times the square root of negative 1, don't forget that, all over 2. Now you'll notice at first I simplified the first term, of course, negative 6 over 2. Now continuing to simplify the numerator in the second term, we get negative 3 for the first term, plus or minus, okay, the square root of 16 is 4. So we've got 4 times the square root of 2, and then replace square root of negative 1 with I. And on the bottom we have our 2. Now, we can cancel a factor of 2 on the bottom with a factor of 2 in the 4 on the top, which leaves 2 up there. So our answer is now negative 3 plus or minus 2 times the square root of 2 times I. Now, that's my answer, and this shows, it demonstrates that whenever you have a complex solution to a polynomial equation like this, you also get the complex conjugate as a solution. And this is just a demonstration that this was indeed what happened. You notice the first answer has a plus sign in the middle, while the second answer is the conjugate of that number. It has a negative sign in the middle.